negatives, which means we can't have negatives, which means x is greater than or equal to 0. And so if I plug in 0 into my x to get out my y, whatever, to get out the y, I have to take the square root of x. So it's the square root of 0, which is 0. So that's how we get that initial coordinate. Right? 0, 0. What's the only thing that can move that point? What transformations can move that point? Horizontal and vertical translations. They're the only thing that can move it. Why can't stretches or reflections move that point? Because it's 0, and stretches and reflections do what operation?
Multiply.
Multiply. When you multiply by 0, what happens? 0. Nothing happens. So radical graphs are really actually quite awesome, because you know if there's a horizontal or vertical translation instantly if that coordinate, if where it starts is not on 0, 0. If it starts anywhere else, there's a horizontal or vertical translation. It's the only thing that can move that 0, 0. Our next one, I always do is 1, 1. It's a nice solid one. And then you can put a whole bunch of decimals. You could go square root 2, square root 3, and do the decimals. I just am lazy, so I do square root 4, which is 2. So I get 4, 2. And then I do 9. Square root of 9 is 3. I draw my parent function. This is a radical graph that has not been moved, right? It's just your basic radical graph with no transformations. So my domain is x such that x is greater than or equal to 0, x the element of the reals. My range is y such that y is greater than or equal to 0. Y is the element of the reals. What are my x-intercepts and y-intercepts?
You only have one answer, 0.
Yeah, so my x-intercept and y-intercept is 0, 0. Now, if I know the parent function, do I actually have to graph anything if I'm given transformations? Do I have to use my calculator? No, you can transform your parent function, right? You could use mapping and move your parent function, could you not? So this next one, B, what transformation is happening there?
2 units to the right.
More than that. What's the wording? Horizontal translation. Yeah. We always write it out properly, so we do not mess up on our diploma and get no marks. 2 units. Right. So I'm legitimately just moving the parent function 2 to the right. Do I need to type it into my calculator, or can I just move those points 2 to the right and work it through? Just do 2 to the right. So 0, 0 is now going to be 2, 0. 1, 1 is now going to be 3, 1. 4, 2 is now going to be 6, 2. And then 9, 3 is going to be 11, 3. Graph like that. Now, did I actually have to do the graph to figure out the domain? I can take what's under my square root and say it has to be what? What is the rule of anything under a square root? It has to be what? Greater than or equal to 0. Remember that equal to sign, because I can have a square root of 0, right? Logs cannot equal 0. They have to be greater than. Yes, we just went over that. Restrictions of a log has to be greater than. Can't equal 0, can't be negative. Radicals can be 0 and positives, right? So I would just go x minus 2 has to be greater than or equal to 0. So x has to be greater than or equal to 2. So the domain in interval notation, if I wanted to, is square bracket 2 to infinity. Has it moved up and down at all? Has the graph moved at all, up and down? So my range stays the same. Range greater than or equal to 0. What's the only thing that can move my domain and range? Technically. Translations, right? Because stretches and reflections keep it at 0, 0. The only thing that can move a domain and range on a radical is your translations. And reflections can make it less than, right? Reflection would cause your inequality sign to flip. You divide by a -1. Or thinking about it, you would be this way. You're now going to be this way. All right. I want you guys to do this one. Just see. I want you to sketch it. I want the transformations. And I want the domain and range. And I'm going to say this like I say every single time, but there isn't going to be a Mrs. Lepp voice on a test, and there isn't going to be a Mrs. Lepp voice on a diploma. What must I ensure that I have? A 1 in front of the x. Do I have it? No. I know that if it is a -1, people will mess it up way more than if it's a 2 or a 3 or a half. They'll remember to take it out. So make sure you take a negative. So here we have y equals 3 square root -1 x minus 1. So if I go to do my domain, I could do it just off that square root. I could go -x plus 1 is greater than or equal to 0. -x is greater than or equal to -1. Divide by -1, and I get x is what? Is less than or equal to 1. Because that negative is going to cause it to flip. Not only is it going to cause the inequality to flip, it's a negative, right? It would normally be up and to the right. It's now going to be to the left. Yes, there's that reflection. You see it in your calculator even when you type it in. So my domain would be related to that. Would my range change? Did this graph move up at all? Down at all? It's a vertical stretch. Does that change my 0? No. So I know my range then is going to be y is greater than or equal to 0, right? It didn't move. Transformations, you have a vertical stretch by a factor of 3 about the x-axis, a reflection in the y-axis, and a horizontal translation 1 unit to the right. Yeah? Okay. This one I told you I just wanted domain and range and transformations. Once again, I did it where I had to have that half taken out. Then you're left with x minus 8 plus 3. But you can do your domain not with that. You can do your domain right from the original. You can go 1/2 x minus 4, bless you, is greater than or equal to 0. 1/2 is greater than or equal to 4, 1/2 x. And then x is greater than or equal to 8. True? Okay, let's think about this graph. Remember, the only thing that can move that original 0, 0 for radicals is the transformations, right? Our domain and range are based off of our transformations. Where did this vertically move? Vertical translation what? 3 up. So I know my range is going to be y something equal to 3. It's going to be greater than if there isn't a reflection. It's going to be less than if there is. Is there a reflection? There's a reflection happening to the y's. We agree? So that's why this ends up being less. Not just typing it into your calculator and looking. So the domain and range actually of radicals are easy. Their number is based off the translation. Their inequality sign is based off of the reflector. If it reflects, it's less than. If it doesn't reflect, it's greater. Right? That's it. Then your horizontal and vertical translations. So let's go through your, you should have these written down. So you have a vertical stretch by a factor of 2 about the x-axis, a horizontal stretch by a factor of 2 about the y-axis, a reflection in the x-axis, a horizontal translation 8 units right, and a vertical translation 3 units up. Yeah? Okay, flipping over. Radicals Determining equations of radicals are easier because if this thing right here is not here, I have translations, correct? So my translations are actually really easy to do. Now remember, radical graphs are up and to the right, correct? Always that parent function was up and to the right. So if your graph is not up and to the right, there's been a reflection. So let's talk about the translations first. So this here, this coordinate is at -3 and 4. So my translations are going to be x plus 3 and a plus 4 at the back. We agree? Reflections are easy. If it's up and to the right, there aren't any. Is it up and to the right? No. It's to the right, which means there's no reflection in the y-axis, but it is down. So there's a reflection in the x-axis, which means I get a negative here, negative y, right? When you have a reflection in the x, it's a negative y. We know that, because that's the words you say when you say reflection in the x. And then, when you look at your parent function, it's a 1 by 1 box from point coordinate to coordinate. You see that? It's just a 1 by 1 box. So when we go to this one, if it's a 1 by 1 box, there's been no stretch. Is it a 1 by 1 box?
Yes.
Yeah. So I'm done. That's the equation. No stretches. So let's look at the next one. My coordinate is not at 0, 0. My initial coordinate, bless you, is at -5, -3. So let's put in our translations. So we get y equals x plus 5 and a -3 at the back. Next, I do reflections. And you can do translations. Normally, you have to do them last, correct? Normally, you always do your translations last. You do all your stretches and reflections first, then translations last. With radicals, we can do translations first because of the fact that it starts at 0, 0. It's the only thing that can move them. Okay. Reflections. It's normally up and to the right. If it's not up and to the right, we have reflections. What is this one? It's up and to the right. So are there any reflections on it? No. Then let's look at the 1 by 1 box. Well, it's 1 by not 1. It's 1 by what? 4. Horizontally. 1, 2, 3, 4 boxes, right? So it's horizontally stretched by a factor of 4. So what do I put in here? 1 over 4. Done. So you do C and D quickly. This one, my coordinate is at 5 and -1. So I can do my translation. Y equals square root of x minus 5 and then -1. Then I check reflections. Is it up and to the right? No, it's still up, but it's to the left. So what am I reflecting on? Which axis? The y, because normally this way, it's this way, right? So it's the y that's reflecting on. When it's reflecting on the y, I get a negative here. Right? And think about the way that you say it. If you say reflection in the y-axis and there's a negative there, then put the negative there, right? That's what you would say. And then we look at our stretch. It's 1 over and 2 up this time. So it's a vertical stretch by a factor of 2. Then let's look at this one. This one's at 4 and 5. I'm going to get y equals the square root of x minus 4 plus 5. Is it up and to the right? No, this is the best one. It's down and to the left. So I don't have to figure out where the negative goes. It's on both, right? Down and to the left means I have a negative here and a negative here. And then my stretch, 1 over, but it's going to be 1, 2, 3, 4 down. So I have a vertical stretch by a factor of 4. That was really long. Now, I just want to let you know that all 4 of these can be written differently. When it's a square root, we can actually stretch it the other way. Because square roots, numbers can come out and numbers can go in on a square root, correct? If I have a number outside, I can bring it in by squaring it. If I have a number inside, I can bring it out by square rooting it. We learned that in grade 10. Everything's from grade 10, I swear to goodness. This one has no stretches, right? So this one's done. I can't change it. This one does have this little quarter here. Could I bring that quarter out? What's the square root of a quarter? A half. There we go. We got there. It's a half. So I would still do it as the quarter because that's the easier way to do the equation. But they might give it as a half in front. So remember that you can take it out, right? Nothing crazy. You guys know that. This one, the vertical stretch, they might bring it inside. How do I bring it inside? Square it. So you bring it in and it comes up? 4. The negative still sits in there. And then this one, same thing. The 4 can come in and it would be a what? 16. Now the only way we know what the stretch is if we have a graph and we can draw that 1 by 1 box, right? It's the only way we can give a stretch. So for these ones, we're given a domain and range. We're not given like what the graph looks like. So we can get the horizontal and vertical translations from this, and we can get the reflections from this. What we can't get is stretches. So if you put a stretch on it, you wouldn't be wrong, because you put any stretch on these, and they would actually still give you the domain and range of those. So this here will give me my horizontal translation, right? So I would have y equals the square root of x minus 5. This would give me my vertical translation, plus 2. Now, we know that the graph, if it has not been transformed, is up and to the right, correct? Up and to the right. Which means if it's up and to the right, let's think about that. If my graph is up and to the right, my domain is x is greater than or equal to, and my range is y is greater than or equal to. Is it not? If it's up and to the right, they would both be greater than, wouldn't they? What's the only thing that can make them lesses? Reflections. This is true. So, this one here is greater. So is there any reflection in the y-axis? Nope. This one here is less. So instead of the graph being up, it's going down. So I have a reflection in the x-axis. Because it has to affect the y's in order to affect range, correct? Range is only affected by the y stuff. So if my y has is a less than, then the negative is going to be with my y stuff. The only thing that affects range is y things. You do this one. This one here, we have y equals x plus 2 in here, minus 4 at the back. This one is greater than, so no reflection with my y's, right? This one is less, so I know I have a reflection here. Could I put a 7 here if I wanted to? I could put any stretch I want. Any stretch is not going to affect it if they only give me domain and range. I can put a stretch in, or I can not put anything in. I prefer to not put extra, because extra means I could get something taken away from me, so I wouldn't even put stretches in, but you could. Okay, then number 4, this one, it should be to root x. I hope you noticed that. A lot of you don't read thoroughly, so you might have totally missed that, which is good if you did. And didn't just do it to an x. But if you did do it to just an x, it should have a square root. Vertical stretch by a factor of 3. A reflection, I don't know what is going on. Okay. A reflection in the x-axis. Translation 4 units right. 2 down. Horizontal stretch by a factor of a quarter. So we're going from words to equation crossed over that arrow. So I get 4. Reflection in the y-axis, negative, I don't know what the board's doing. Translation 3 units up. And 5 units left. So we have to make sure we have it in brackets when we do that horizontal translation, because it has to have a 1 in front of it in order for our horizontal translation to be right. Now after, if they didn't have one with brackets, you would distribute the -4 and then you get -20, right? You do that after the fact. Here we have a vertical stretch by a factor of 2 about the x-axis, a horizontal stretch by a factor of 3 about the y-axis, a translation 1 up, 4 left. And then here we have a vertical stretch factor of 3 about the x-axis, horizontal stretch by a factor of a half about the y-axis, reflection in the x-axis, and reflection in the y-axis, and a translation 6 left. Little side note as a remembrance, had I given you this, say this was the original, and I told you it was vertically stretched by a factor of 2, what would you have to remember to do?
Add the 3 to it every time.
Yeah, distribute that 2 through, because it stretches all the y's. Remember that from transformations? All the y's. So it would go in front of here and join that 1, but it would also join this. So if I had a vertical stretch by a factor of 2, it would be 2 root x plus 6. Remember how everyone kept forgetting to do that? Yeah. Your homework is to work in this booklet. Tomorrow I'm going to go through the whole thing. I'm probably doing half the thing. And you need to be done at least the first 2 pages, preferably third. The answers are on the back, so you'll know if you're right or not. I'm still going to go through. Oh crap! I'm still going to go through them anyways because I catch little things or tell you little things about, like, remember this about graphs, remember this about it. You have no homework on this because we did the homework in class specifically so that I could give you guys time to work on this. Okay?